All right, so we're looking at 8.5 today and start out with number 1. So number 1 says we have a circle and the radius in that circle is 10. The length of AB, which is an arc, is 14. So here I'm told the radius length is 10, so that's going to be 10 here and 10 here as well. And then I am told that I have the length of arc AB as 14. So if I want to know the perimeter of the shaded area, it's bounded by red, red, and orange here. So I'm going to add these things up. So I'm going to do 10 plus my 14, 34. Boom, I'm good to go. Any questions on this one? Perfect. Let's look at number 17 here. So here I want to find the exact perimeter of the area of the segment shown. So here is the segment, this little blue kind of shaded in spot right here. So when I'm looking at this, I'm given that angle O is 60 degrees. So as my central angle here is 60. Now that is very helpful because that's a type of triangle that we're pretty comfortable working with. Here I have OA is 12, so I'm told the length of this radius is 12, so it's going to be 12 over here as well. And we know since this is 60 here, that this is also going to be 60, 60. Therefore, this is going to be 12 as well. The reason we know that is because once I have my central angle, I know that it creates an isosceles triangle. It just happens to be that since this is 60 and there's 120 left, my 120 equals my 2x, so therefore it makes x 60 and 60. So that's where we get all three angles are congruent. So that's how I got my 60, 60, 60 equilateral triangle here, and it's also going to be equiangular. So as we see this thing, I say, okay, if this is 12 and this is 12, then this is 12 as well. And now we have one of the sides of my segment. So I'm going to try and draw the segment below here, just identifying that we found this is 12, and now I'd like to find the length of this arc here. So arc AB, in terms of the length, is going to equal the measure of its central angle over 360 times the circumference. So first thing I want to figure out is the circumference. Well, my circumference equals 2 pi r. In this problem, we're given that r is 12. So my circumference here is going to be 24 pi. So now here, this is going to get substituted in, and I want to know the central angle here. We got 60. So I get 60 over my 360 times 24 pi. And so this is just 1/6. So 1/6 of 24 is 4. This is going to be 4 pi. So the 4 pi part is the arc, and that's right here. So if I want the total perimeter in exact terms, it's going to be 12 plus 4 pi. And I'm good to go. Any questions on 17?
I'm pretty sure you still have to find the area of the segment too.
Oh, perfect. Let's find the area then. Okay. Thank you. I only read half the question. There we go. So let's find and area, since we want to be completing the problem and reading all the words. Let's look at the area for this thing. So the area of this thing is basically going to be, area is going to equal the sector subtract off the triangle. So when I say the sector, I'm talking about, I'm out of colors here. So here's the sector, right? It's this kind of like wedge of cheese looking thing. And what I want to take off is the triangle. So this triangle is separating it right here. So if I do the area of the sector, that's going to be m over 360 times my pi r squared. It's supposed to be an r there. And that's the area of the circle. So I'm saying this chunk of the circle. And then for my triangle, since we know this is an equilateral triangle, we have a pretty easy way of determining what the area is. I'm going to write that formula. So this is for an equilateral triangle here. So for equilateral triangles, I will typically just do side squared divided by 4 times, oops, there we go, root 3. It's quick and easy. If you don't want to do it this way, you don't need to. So basically 12 squared gives me 144. 144 divided by 4 gives me 36. So it's going to be 36. Well, I don't know. I'll just write this formula down here just so we have both general things. Maybe I won't. There we go. So subtract off the area of that triangle. And now let's actually fill in those values here. So in terms of what these things are, the area of the sector part here is going to be 1/6 of, now I'm going to say my pi r squared, so this is going to be 144 pi, oops, because my radius here is 12. So again, I'm getting some pi values here where we got 24 pi. And then I'm going to subtract off, and now I've got my 144 divided by 4, which gives me 36. So it's 36 root 3 pi. So in terms of my final answer, it would be 24 pi minus 36 root 3 pi. Hopefully that's semi-legible there. Any questions on that one? Oh, sorry, I don't know why I put pi in here. There's no pi there. That's a joke. I can even do it in black, so it never happened. Yeah, the triangle has no pi stuff. That was a moment of delusion. Any questions on this one? Perfect. Good catch on doing the entire second half of the problem there. All right, 21. So we're assuming the exact area of a sector is determined by a 40-degree arc. Let's draw a picture because pictures are nice. So I'm saying here we have, oops, not 540, just 40. And we're calling that area this thing. I'll include the centimeters squared because why not? Okay, so find the length of the radius of the circle. So if I know that this is the area for this sector, so, you know, all the stuff in here, then what I can do is just back my way out by plugging in what area equals. So area equals the central angle over 360 times pi r squared. So now I'm just going to solve for my r value by plugging in the fact that I know that m is 40. So let's plug in some numbers here. 9 over 4 here. So I'm dividing both sides by pi. Divide by pi, divide by pi, that cancels off. M over 360, so 40 over 360 gives me 1/9. So again, this 40 is being, whoops, not a good circle. 40 is being plugged in right here. 40 over 360 just simplifies to 1/9. And this is r squared. I'm going to multiply both sides by 9. So I multiply by 9 over here. I multiply by 9 over here. So I get 81 over 4 equals r squared. So now from here, I'm going to take the square root, take the square root. I'm only going to keep the positive one. So it ends up being 9/2. There's my r value. Any questions on this one? Perfect. Here's a fun problem. So we want to determine the formula for the area of the shaded region determined by the circle and the inscribed square. So all we're doing is coming up with an equation for this one. So we don't actually have like a side length to solve for. If we gave a side length, like if we just said, okay, the side length is 10 or whatever, then, you know, obviously we could solve for it. So in this one here, the tricky part is identifying that this is not the radius of the circle, but there is a way to figure out the radius of the circle using this thing. So let's first talk about the area of the thing that I want. So the thing that I want is in blue. Let's write it in blue. So area of the shaded part is going to equal the area of the circle. So we'll do the circle. Oh my goodness. In green, and we're going to subtract off the area of the square. And that's going to be our shaded area that we want. So here, I'm going to start talking about this thing, but this is the one we have to figure out still. So I'm going to put a diagonal across here, which would be the diameter of my circle. So keep in mind that I do know a square has all the same sides. So if this is S, that means this is S. This is a square, so I know this is going to be split in half into a 45, 45, 90 triangle, which makes this S root 2. So if this is S root 2, my diameter for the circle is equal to S root 2. And so if I want the radius for the circle, I don't know how important colors are, but so radius is just going to be S root 2 over 2. Cool. So now that I know the radius for the circle, I can figure out what its area is. So my area of the circle is going to be pi r squared. And the area for the square is just going to be side squared. So for this, I'm going to plug in my radius here. So now everything is in terms of s's. So I would say I get pi times, now here I'm going to say s square root 2 over 2 squared, and then I've got minus my s squared here. So I'm going to just do this out. So this is going to be pi on the outside, or I get s squared times 2, all divided by 4. This is going to cancel off, so I just get 2 on the bottom here. So I get pi s squared over 2 minus s squared. And that would be my final answer for the area of the shaded region here. Any questions on this one? Perfect, perfect. There's multiple ways you can write this too. You could write like the pi over 2 on the outside and then just the s squared kind of on level. Like, again, as long as you don't write the s squared specifically in the denominator, you're fine. Looking at 31. So we got company logo on the side of a building, isosceles triangle, inscribed circle. If the sides of the triangle measure 10, 13, 13, find the length of the radius of the inscribed circle. Okay, cool. So to solve this problem, we need to know that the area for this triangle can be represented multiple ways. So one of the ways I can represent this area is 1/2 base times height. Another way is I can represent it as Heron's formula, so semi-perimeter times S minus A, where A is a side length, semi-perimeter minus B, where B is a side length, and then semi-perimeter minus C, where C is a side length. And then a third way, which is the way that I want to focus on, is it's going to be 1/2 the radius of the inscribed circle times the perimeter. So this is the one that I want to focus on. So my perimeter here is going to be 13, 13, and 10. So it's going to be 36. So P equals 36. And now I'm just going to solve for this R value once I figure out the area of this triangle. So plugging 36 into this formula, it's going to be 18R. So my area equals 18R, and that's what I want to work with. So I just need to find another way of solving it. I personally think I would probably go this route, but if you want to go Heron's formula, whatever floats your boat, we'll end up at the exact same place, so it really doesn't matter. So let's look at 1/2 base times height. If I have an isosceles triangle, oops, then I should be able to drop an altitude down like this, it'll split this into 5, and then this is 13 here for my hypotenuse, and then I have a right angle. So I'm trying to figure out this height here. Let's just call it b. I don't know what it is, but I know b squared plus 5 squared equals 13 squared. I do my Pythagorean theorem stuff, and I get b equals 12. So now that I know b equals 12, I look at this and say, okay, well, my height equals 12, my base equals 10. Let's plug these in to this equation right here. So now I'm going to say, okay, well, 1/2 base times height is going to give me 60. So if 60 equals, what the heck, there we go. If 60 equals 18r, then I'm just going to then divide both sides by 18. Let's say, so I'm just going to break this one step at a time. So one thing I notice is I can, divide by 2. And then my next step is I could divide by 3. So my R value here equals 10/3. Any questions on this one? Perfect. If you want to put this back into like whatever the unit is, we're talking about feet here. So yeah. So here we have a triangle with sides ABC and semi-perimeter S. So we're just showing that the length of the radius of the inscribed circle is this. So this jumps back, I'm gonna grab this, to exactly what we just did. And let's see how. So looking at the problem that we just did, my radius here, if I wanted to isolate this radius, what would I have done? If this is my formula, all I'm saying is area is one way, or excuse me, one way to represent the area is to talk about it like this, right? This is Heron's formula. That's my area. Okay, and then I'm saying equals 1/2 the radius times perimeter. Well, look what's happening here between this equation and this equation. If I wanted to get r by itself, what would I do? I would multiply by 2. There's my 2 there. And then what is my perimeter? Perimeter's right here. That's what I would be dividing by after I multiply by 2. So times 2, divide by perimeter, that's how I get r by itself. So here it's really just comparing area formula for Heron to area formula for an inscribed circle with a radius r. So that's what this problem is getting at. In terms of showing it, I feel like we pretty much just showed it above there, but that's how you would get there step by step. Any questions on 33? Perfect. I think 35 is the last one, yeah. So here's basically just saying plug the numbers in. So use the results from 33 here. So there we go. And now we want to find the length of the radius of the inscribed circle for the triangle. So this is literally just plug and chug for numbers. I assume you guys can do this, but if you want me to do it, I can. The first one I think comes out to be 3, and the next one comes out to be 2. So it's fairly straightforward in terms of like plugging the numbers in, but again, if anybody wants me to do this out, I absolutely will. So the only like interesting part, I guess, to go from here to here is that my perimeter equals A plus B plus C, and that my semi-perimeter equals 1/2 of my perimeter. So in terms of like other things you could even, consider are like steps or aspects of this problem, that would be it. Any questions on this one? Again, if anybody wants me to plug these values in, I absolutely will. Cool, cool. All right. That wraps up 8.5 for us here. Whoops. There we go. Cool.